Good morning, algebra students. We're going to continue learning about point slope form, slope intercept form, all different sorts of equations that have to do with slope and the different ways that you can use it. You've received your vocabulary, page 28 for this lesson, which is lesson 5.2. This is about writing equations in standard and point slope forms. You already know how to write equations in slope form. This particular example is point slope form. Your definition is here. Here's your definition, which states the equation of a straight line in the form of, it takes the form of y minus y1 equals m in parentheses x minus x1. M is the slope, and x1 and y1 are two coordinates that are given on any point of a line. It's an ordered pair. And you can use any x and y pair on the coordinate plane that you want to. Your example is right here, and I want you to label anything. Any point for y, any point for x. M is the slope. And then x1 and y1 are known points, which are the same as your ordered pairs. And keep in mind that y and x can be any point that you choose. And that's really how you would solve this equation. Your sentence, I want you to put this in your own words. Like, for instance, I want you to maybe, I'm going to click down here. How would you use point slope form? If you know the slope, you could certainly use it there. And if you know 2 points on the coordinate plane, you can certainly use it there. And eventually you'll get your y equals, which will eventually put it into, y equals mx plus b. So that's one way you could use it if you don't necessarily know what's going to go with the m, and if you don't necessarily know what the y is. So that's one way that you could use it. Go ahead and put your definition in your map or on your vocabulary sheet, not your map. Our next definition is a parallel line. And hopefully you remember what parallel means. The definition is they're non-vertical lines in the same plane that have the same slope. When you think about parallel lines, hopefully you think about lines that look like this. And you should notice from transformations that if they had the same slope, that these were also parallel lines. So they could be vertical transformations, horizontal transformations, depending on if they go up or down. That's why we learned about transformations. And in your sentence, make sure you give an example. In your sentence, you can also say that they're equations that have the same slope. Our final definition is perpendicular lines. So they're non-vertical lines in the same plane for which the product of the slope is -1. So a perpendicular line might be this, it might be this, it might be, it can't be vertical though, might be this. So it's really where X marks the spot. So your definition is on the board, give a good example, and in your sentence, it's really your transformation that has the opposite slope. So that's your sentence for perpendicular lines. Parallel lines have the same slope. Perpendicular lines have opposite slopes. We'll learn more about these in class. We'll do some examples. Make sure that you illustrate something with parallel lines, and make sure you illustrate something with perpendicular lines. And you might find something in your house that maybe illustrates that. Be sure to put these in your yellow folder.